Okay, let's do a problem here where we're talking about the change in energy and heat and work and how those things work together. And we have a system set up here where we have a piston inside of a water bath. Inside of this piston there is a chemical reaction going on, and we're going to consider that this is the system and the surroundings are everything else, but in particular this water bath. And so what are the exchanges, the changes that are going on between the system, and which is this piston, and the surroundings, which is going to be mainly represented by the water bath? Okay, so it says from previous experiments, this chemical reaction is known to release 266 kilojoules of energy. So we have to go back to those definitions that we should have in our mind. And that is this, that if a system releases energy, then the sign is going to be negative. If the system releases heat, then the sign is going to be negative. And finally, if the system does work, then the sign is going to be negative for work. And the opposite is true. That is, if energy comes into the system, then the sign is positive. If heat comes into the system, then the sign is positive. And if work is done on the system by the surroundings, then the sign is going to be positive. Now let's think about that piston. If the system does work on the surroundings, it's going to push that piston out. Okay, and finally, if work is being done by the surroundings on the system, then that's going to push that piston in. Okay, so armed with those definitions here, then we also know from our equation that the change in energy is going to be equal to the heat plus the work. Okay, so it says from this experiment, from previous experiments, this chemical reaction is known to release energy. Okay, so if the system releases energy, energy is going out, the sign is negative. Okay, so we know that the change in energy is going to be a negative 266. And finally, it says the temperature of the water bath is monitored, and it is determined from this data that 235 kilojoules of heat flows into the system. And so if heat flows into the system, that is positive. And so Q is going to be a positive 235. All right, and it's going to ask us then about the piston moving and work and how much work. Can we quantify that work? Okay, so we know that delta E, which is minus 266, is equal to Q, which is going to be 235, plus the work. All right, so if I solve for work, then work is going to be equal to a minus 501. That negative sign tells me that the system is doing work, and that piston then has to be going out. It has to be being pushed out. All right, so let's answer these questions. Is the reaction exothermic or endothermic? Well, again, let's look at the sign of heat. That will tell me those things. The sign of heat is positive. If the sign of the heat is positive, that is endothermic. Heat is coming into the system, and so that is making this water bath cooler. All right, the heat is moving out of the surroundings, the water bath, and into the system, and so that temperature has to be going down for sure. Does the piston move in or out? Well, the negative sign on work tells me that the system is doing the work, therefore that piston is going out. It's being pushed out. And so it's going out. That means that the system is doing the work. It means it's doing the work. And how much work is it doing quantified wise? That'd be negative 501 kilojoules. All right, so again, it's just so important. If I had a problem like this on a test, or even as I'm doing my ALEKS, I'm just going to quickly write those down. That is, if energy is flowing out of the system, it's negative. If heat is flowing out of the system, it's negative. If the system is doing work, the sign is negative. And then the opposite of those is true. That if energy is coming into the system, the sign is going to be positive. If heat is coming into the system, the sign is going to be positive. And if work is being done on the system, then the sign is going to be positive, meaning that piston is going to be pushed down in that case. So just think about those definitions, think about what's going on, and these problems can definitely be done.